Hi guys, welcome back. So today we are going to wrap up our unit on solving radical equations. In round one, we were solving radical equations that only had one radical. Round now, we are going to be solving radical equations that have two radicals, okay? The strategy to solve a radical equation that has two radicals is kind of similar to what we did in round one. So if you have yet to watch round one, please do so now and then come back to this vid. Okay, so we have a lot of guidelines. I'm not gonna read them to you because that's kind of boring. You want to take a screenshot, go for it, but let's go ahead do this. So we have two problems, A and B, and then we're out. Okay, so we are asked to solve this equation. We have cube root of 2x plus 7 minus cube root of 3x minus 2 is equal to 0. When it comes to solving radical equations, the first thing we need to ask ourselves is this: how many radicals do we have? One or two? So if we only have one radical, then we're going to isolate that one radical that we see. But if we have two radicals, then guess what? We need to fix it so there's a radical on each side. If you want to say it more concisely, then isolate one of the radicals. But in English, fix it so you have a radical on each side of the equation. I can care less which of these two you decide to move. For me, the subtraction sign really affects with my flow. So I'm going to go ahead and move that second term so that way like both radicals could be positive. Okay, so let's go ahead add. Let's go ahead and move that second radical. So to undo a subtraction, we're going to go ahead and add it. To undo the subtraction by cube root of 3x, let's go ahead add cube root of 3x. 3x minus 2. Okay, I need to finish the rest of the radical. Okay, once we add that radical to both sides, that will leave us with cube root of 2x plus 7 is equal to cube root of 3x minus 2. Cool, fantastic. So step number one, if you have more than one radical, step number one is to fix it so you have a radical on each side. Step number two, try to clear at least one of the radicals. The reason why I say try to clear at least once is because sometimes by working our magic, both radicals are gone, but sometimes even if we work our magic, one of the radicals may still exist. To undo at least one of the radicals, we are going to raise both sides to a power equal to the index. So in this case, the index is 3. To undo the index of 3, let's go ahead raise both sides to a power of 3. Okay, so if you want to impress your friends, let's go ahead cube both sides. So on the left side, index of 3, power of 3 undo each other, and that will leave us with 2x plus 7. On the right side, it's going to be the same speech. Okay, index of 3, power of 3, they're the same number, so they undo each other, and that will leave us with the radicand of 3x minus 2. So now we are going to focus our energy on solving our new equation. So when we solve this equation, we have to ask ourselves, what kind of equation is it? Is it linear, quadratic, all that good stuff, you know, the usuals. In this case, we have a degree 1 equation, so let's old school it, linear equation. We want variables on one side, non-variables on the other. I said it before, I'm afraid of negative coefficients, so with your permission, we're going to move the term that has the smaller coefficient, namely the 2. But if you want to fix it so the variable is on the left, I'm all for it. Okay, if you decide to subtract 2x from both sides, then that will leave us with 7 is equal to x minus 2. Fantastic. To finish it off, to get rid of the subtraction by 2, inverse operation of subtraction is addition, or you know, who has time for that? Just opposite of subtraction is addition. Let's go ahead, add 2 to both sides, and that will leave us with 9 equals x. Okay, so I don't think we made a mistake, like an arithmetic mistake or an algebraic mistake, so we know we nailed it. But remember, when it comes to solving radical equations, checking is not optional. We have to check our answer, our proposed solution, to eliminate any extraneous solution. So let me go ahead write down the original equation, and that way we will check our answer with confidence. And I say that because I have a tendency to put the numbers in the wrong place, but if I write down the equation, then that will minimize That will minimize the likelihood of me putting the numbers in the wrong place. So we have cube root of 2 times x, okay? And our proposed solution is 9 plus 7 minus cube root of 3 times x. So 3 times x, and our proposed solution is 9 minus 2. And for my peace of mind, this needs to equal 0. So let's see. So that will give us cube root of 2 times 9 is 18. I know you can add 7 right now, but you know what? When you're tired, you just can't do so many things, okay? And even if I'm not tired, you know what? What's my name? I forget. So I only like to juggle with 2 things at a time. Product of 3 and 9 is 27. And when we clean this up, for our peace of mind, difference needs to give us 0, okay? Sum of 18 and 7 will give us 25. Difference of 27 and 2 is 25. Now, I am trained to simplify the radicals, but they're already simplified. But even if they weren't, cube root of 25 minus itself, you guessed it, something minus itself is 0. So to answer my question, is my proposed solution an actual solution? Does 0 equal 0? Well, last time I checked, 0 does equal 0, so 9 is a solution. So remember, when it comes to solving radical equations, checking is not optional. We have to check our answers to eliminate the extraneous solutions. The worst thing you can do to yourself is like nail the algebra, but then get dinged because you failed to check your answer. The only way you're gonna know if you have an extraneous solution is by checking. We just can't eyeball it. So I said we were gonna do 2 problems. That was our first problem. Lucky for me, I'm already prepared. So let's do this problem and we're out. Okay, so problem B. We are asked to solve this equation. So we have established that we already have a radical equation. So the question that I'm going to ask myself is this: how many radicals do we have? 1 or 2? In this case, we have 2. Okay, so now what are we going to do? We are going to fix it so we have a radical on each side, or concise, isolate one of the radicals. I can care less which of these 2 are you going to move, but I'm just going to move the second one because it's just easier for me to, for aesthetic reasons. So when we subtract, or if we subtract the square root of x plus 1 from both sides, let's take our time and then write down what that will leave us with. Okay, so that will leave us with the square root of 2x plus 3 is equal to whatever your heart desires. We can put 1 minus the radical, or we could put the negative radical plus 1. For aesthetic reasons, I'm actually going to put the radical at the end. So we have 1 minus square root of x plus 1. Okay, but the real reason why I put the radical at the end is because I'm afraid that if I put the 1 at the end with tired eyes, I may think that this one is part of the radicand, and we don't want to do that. So I do it for protection, okay, to serve as a separator. Okay, to solve a radical equation that has more than one radical, well, to be more specific, to solve a radical equation that has 2 radicals, our first goal is to fix it so we have a radical on each side. Okay, our second goal is to try to get rid of at least one of the radicals. How are we going to do that? We're going to raise both sides to a power equal to the index. So in this case, we got a square root, or index of 2. To get rid of a square root, let's go ahead, raise both sides to a power of 2. Okay, so on the left side, the square and the square root undo each other, and that will leave us with the radicand of 2x plus 3 equals, I have no idea on the right side. I know you're on it and you can like quickly multiply by using the multiplication shortcut, but this is out of my comfort zone, so I'm going to try to minimize the mental math with your permission. We're just going to write it without the exponent. So we're going to write 2 factors of this base. Okay, we have 2 factors of 1 minus square root of x plus 1. So let's go ahead, take our time, and see what the right side gives us after we simplified. Let's go ahead, FOIL it out. Product of the first terms, namely 1 in itself, will give us 1. Product of the outer terms, positive something times negative something, will give us negative something. And 1 times the radical is just the radical. Okay, so that will leave us with just minus square root of x plus 1. Product of the inner terms, negative something times positive something will leave us with negative something. Square root of x plus 1 times 1 is just square root of x plus 1. Product of the last terms, negative something times negative something will give us positive something. And the square root of x plus 1 times the square root of x plus 1 will give us 2 factors of the square root of x plus 1. Okay, let me go ahead and write it so I can convey what I want to say. Okay, so we got square root of something times square root of something, or square root of something squared. Okay, let's take our time, clean this up, and then we'll come together to strategize to see what we do next. Okay, so the left side, there's nothing to do, it's already simplified. The right side, let's simplify what we can and combine what we can. We only have one constant term. We got two radicals. When we combine them, the numbers before the radical is negative 1. Negative 1 minus 1 is negative 2. So that will leave us with negative 2 times the square root of x plus 1. For the fourth item, we got a square root. And we are asked to square it. So same speech. The square and the square root undo each other. And that will leave us with the radicand of x plus 1. I'm thankful that we have a plus sign before it, so that makes things a little bit easier. So we're going to add x plus 1. Okay, this is a lot of information for me, so I'm not trying to ask myself what am I going to do to both sides to solve it. I just want to continue to clean the right hand side. So that will leave us with 2x plus 3, and this is how it's going to go down. I'm going to first put the variables, then the constants, and then the radical at the end. We only have one variable term. Let's bring it down. The sum of the constant terms, 1 plus 1. I should differentiate. The sum of the constant terms, namely 1 and 1, will give us 2. And then we have that radical, minus 2 times the square root of x plus 1. Now, what is the difference between problem B and problem A? In problem A, we were lucky that just by squaring both sides, just by raising both sides to the third power in one click, we were able to get rid of the radical. Okay? In problem now, it's not as straightforward. Once we use the power rule by raising both sides to a power equal to the index, although one of the radical is gone, we still have an existing radical. The question is, how are we going to solve it now? At this point, since we only have one radical, we're going to pretend like this is a brand new problem and start from the beginning. To solve a radical equation that has one radical, our first goal is to isolate that one radical. So if you're not with the radical, you gotta go. Let's go ahead, subtract x from both sides. And when we're at it, we'll subtract 2 from both sides. When we subtract x and 2 from both sides, that will leave us with x plus 1 is equal to negative 2 times the square root of x plus 1. Okay? How are we going to solve a radical equation that only has one radical? Our first goal is to isolate that one radical, but this is where I'm going to bite my tongue. I am supposed to work my magic to isolate that radical. So I'm supposed to ask myself, what am I going to do to get rid of that times negative 2? To get rid of that times negative 2, we're supposed to divide by negative 2. But check it out. Negative 2 does not go into x and 1 a clean number of times. That means that if we divide both sides by negative 2, we're going to end up with fractions, and who has time for that? So let me go ahead and revise it. When you are solving a radical equation that has just one radical, try to isolate it as much as possible. If it turns out that for the greater good you have to multiply it by some number, so be it. You just don't want to add or subtract the number from it. Okay, so isolate that radical as much as possible, and now we're going to go ahead raise both sides to a power that's equal to the index. So because we have a square root, then the index is 2. So to get rid of the index of 2, we're going to raise both sides to a power of 2, or square it. Okay, so on the left side, you're going to square it however you like. You can square it by using the multiplication shortcut, but with your permission, today is not a shortcut day. I'm just going to go ahead FOIL it out. Okay, so we're going to go ahead rewrite it without the exponents. On the right side, we have two things to square, namely the -2 and the square root. The square of -2 will give us 4, and we're going to multiply it by the square of the square root. The square and the square root undo each other, and that will leave us with the radicand of x plus 1. Okay, so let's go ahead and wrap it up. Okay, radicals are gone. Let's just go ahead, simplify each side, and then take it from there. So on the left side, let's go ahead, FOIL it out. Product of the first terms will give us x squared. Product of the outer terms will give us x. Product of the inner terms will give us another x. And the product of the last terms is 1. Okay, what a workout. Who needs to run? On the right side, let's take our time and distribute that 4. Product of 4 and x is 4x. Product of 4 and 1 is 4, and we're on it. Let's continue to work our magic, and in this case, simplify the left side. When we combine the like terms, the sum of x in itself will give us 2x. And then we're going to bring down the rest of the problem. Fantastic. So we had a radical equation with two radicals. They're both gone, so we're good. Let's look at our resulting equation. We have a degree 2 equation or quadratic equation. So let's go ahead, solve by factoring. And if it's not factorable, then we bust out another technique. So as a gentle reminder, how do we solve quadratic equations by factoring? To solve a quadratic equation by factoring, 1, we have to set the equation equal to 0, and then 2, we factor completely. So let's, since the square term is on the left and the leading coefficient is positive, let's go ahead, shift the terms to the left. So to do that, we're going to go ahead, subtract 4x from both sides. And since there's a space for it, why don't we go ahead, subtract 4 from both sides. Usually I only like to move one term at a time, because when I do too many things at once, it messes with my flow. But sometimes I'm a little adventurous, and when there's a space to line up another term, let's go ahead and do this. Okay. So after we subtract 4x and 4 from both sides, that will leave us with x squared minus 2x minus 3, and that equals 0. So we are going to solve this quadratic equation by factoring. So to solve a quadratic equation by factoring, step 1, set the equation equal to 0. Step 2, factor completely. When it comes to factoring, prerequisite step is to watch out for common factors. We don't have any. Now, what kind of polynomial do we have? We got 3 terms, or trinomial. For trinomial, I'm always going to ask myself, is the leading coefficient? And I'm hoping that it is. Okay, if the leading coefficient is 1, we don't have to use the AC method unless like you're like a diehard, but no, if we don't have to, then I'm not going to. Okay, so we're gonna go ahead, throw down parentheses, and work our magic to build the product of the first terms. Product of the first term should give us x squared, and in this case we're gonna use the variable times itself. To complete the binomial factors, we want factors of c that add up to b. We want factors of -3 that add up to -2. 3 is a prime number, so if 1 and 3 is not working, then we have a situation. In this case, the larger factor will have to be negative. Okay, so let's go ahead and check it. Product is -3, sum is -2, so we're good. If one side number is 1, then one binomial should have to read x plus 1. If the other side number is -3, then the other binomial will have to read x minus 3. The toughest part about solving a quadratic equation by factoring is the factoring part. At this point, we got it. So at this point, we will apply the zero factor property. So the zero factor property states that if a product equals 0, there's no way around it. One of these factors will have to equal 0. Either the first factor equals 0 or the second factor equals 0. Okay? If the first factor equals 0, after we subtract 1 from both sides, that will give us to a proposed solution of -1. If the second factor equals 0, then that will give us to a proposed solution. Sorry, it's hard for me to say that word. Okay, that will give us a possible solution of 3. Now, I know we nailed the algebra. I know we didn't make a mistake. But once again, when it comes to solving radical equations, checking is not optional. We have to check our answers to eliminate the extraneous solutions. So let me go ahead, zoom out. No, if I zoom out, it's going to be too small. So you're just going to have to trust me. So I'm going to check the first answer, the one that we got, namely -1. Yeah, it would be nice if you can see that. Sorry. Okay, you know what? It's okay. Let's go ahead and use another paper. Okay. No, it's okay. I like trees. Okay. This is what happens when I go off script. Okay, so let's go ahead and check our first proposed solution, -1. Okay, under normal circumstances, I will rewrite the equation, but since I'm running out of space, I'm just gonna go ahead and plug it in. Okay, let me go ahead and see if I can project the original equation. Yeah, barely. Okay, so we have square root of 2 times x, which we say is -1, plus 3. When we add to it the square root of x, which is -1 plus 1, for my peace of mind, I need it to equal -1. Okay, it's -1? No, it's +1. Okay, see, I told you this is why I need to write down the original equation to avoid these technical difficulties. Okay, so let's clean it up. Product of 2 and -1 is -2. Sum of -1 and 1 is 0. Okay, sum of -2 and 3 is 1. Square root of 0 is 0. Square root of 1 is 1. And to answer the question, does our answer check out? 1 plus 0 is 1, so it checked out. If you wanted to finish it off, then go ahead, add it up, and then confirm that it checked out. So we have that -1 is a solution. Now, just because -1 is a solution, that doesn't mean that the other one has to check out, or doesn't mean that it's not supposed to check out. Okay, so we're gonna check it. So we have our proposed solution is 3, and again, I can't project the original equation without like zooming out a lot, which defeats the purpose of me writing it anyway. So you're just gonna have to trust me. So the equation reads 2 times x. Okay, x is 3. Square root of 2x plus 3 plus square root of x plus 1. So square root of x plus 1. So that will be 3 plus 1. We're substituting the 3 for x is equal to 1. So again, I apologize. It's not my style to go plug and chug. I always write down the equation, but if there's no space, then there's no space. Okay, product of 2 and 3 is 6. Sum of 3 and 1 is 4. Sum of 6 and 3 is 9. Square root of 4, where am I, is 2. Square root of 9 is 3. And the question of the hour is the sum of 3 and 2 equal to 1? Who speaks like that? Is 3 plus 2, does it equal 1? And the answer is no. Okay, if you wanted to finish it off, then go for it. So the question that I'm going to ask myself is this: does 5 equal 1? It does not. Okay, so when something doesn't check out, you know, for me, I have a tendency to second guess myself. That is a bad quality about me. Okay, when it doesn't check out, my first reaction is, oh man, I made a mistake, let me go ahead and find it. But again, when it comes to radical equations, we are prone to extraneous solutions. So again, an extraneous solution is a solution of one of the new equations, but not of that original equation. So in this case, we have to trust ourselves and be like, if it doesn't check out, all right, it's just an extraneous solution. So in this case, -1 checked out, but 3 didn't. So let me go ahead, cross it out for my protection. So I said it before, if I don't cross it out, I'm gonna get nervous and box it by mistake. So what is the answer? We had 2 possible answers. One couldn't fly. We have something to go by. So the solution is just -1. Remember, just because you have an extraneous solution, that doesn't mean that there's no solution. We can't use those words liberally. We can't sprinkle it all over like we sprinkle hot sauce. Okay, we only write no solution if there's no solution, meaning you have nothing to go by. Okay, Look at the other video so that way you can see an example. Okay guys, that's my time. I'm out. Thanks.